Hello, I am Håkon Toftaker and I work as a researcher at Sintef Energy. I will present some work that we did in TwinLab to detect a crack in a turbine runner based on experimental data. So the data was collected at a test rig at NTNU Waterpower Laboratory. This is work done by a master student, Gine Kirkebøen Stern, and she also did a number of analyses to see what can be done based on this data. On the right we see the different sensors placed in the test rig, and here we see pictures of the crack propagation that was induced on the turbine runner. So on level 0 there is no crack, while at level 8 and 9 there is a shark bite gone from the turbine runner. We transferred this data into TwinLab to see what we can do with it there. So we go over to our Jupyter notebook here on TwinLab, and here we have different libraries available to us, and which can be loaded here. On the left we have a pane that shows different files in our local library, or like local storage space, where we also have the master's thesis that we can view here, and then we can do the analysis by starting to import the libraries. We have a number of different libraries available in TwinLab, and then we have we can write text in Markdown, which renders nicely like this and gives an introduction to the analysis. We can load the data. The data is available in a zip archive on TwinLab, and we can load that into different files. That takes a bit of time, so here we have already done that before, and we have the files lying on the left here. Then we define a function to read the data from the different files that we extracted, and we load the data, one data frame for each crack propagation level, like that, and we can view that data frame, one of the data frames, in the notebook in a couple of seconds. They're right there. So this is what it looks like, and then we can see what the names of the different columns, what sensors that they correspond to, by reading that from the extracted files. So here we have an explanation for each of the columns. The data needed some pre-processing, and this pre-processing is based on the description in the master's thesis. So this is to correct for the variable speed of the turbine runner in the experiments. This pre-processing takes a bit of time, but we can run it here, or as we have already done this before, we can save this in a pickle file, and that we have in our local storage. So then we can just load the data from the pre-processed data from the pickle file, and then we have that in the data frames. Now we continue by analyzing the pressure data. So we extract a number of revelations from the data, 53 revelations, and we analyze the mean of each position over all of these revelations. And this can be plotted here, and we can see now that for this pressure sensor we can see that level 0 and level 1 deviate quite a lot from the rest, which indicates that it is possible to see the difference between level 1 and the rest. And this was done in the master's thesis. So to extend this analysis, we have done some principal component analysis of the same data, where we want to find this transformation W, which makes the columns of the matrix T uncorrelated. So we define a function to do a principal component analysis for unsupervised learning there. And then we can view the principal components for pressures, one of the pressure sensors like this. In a couple of seconds it will show. And yes, so here we see, for instance, principal component 5 at the different crack propagation levels. There you see level 0 and 1 are quite similar, while the other ones deviate. So this indicates that we can actually see this crack propagation by analyzing principal component 5 of this data. So we can also do that for the other pressure sensors. And then we can view some selected principal components for this pressure sensors in the draft tube. Now here we see that for the sensor 1 we see the difference, and for sensor 4 we see the difference, while for 3 it's less clear. For guide vane it's more clear that the difference can be seen in the pressure data. So, and here also you can see more a clear trend from each level. We also compared this to a more traditional analysis based on fast Fourier transform. And so here we have the frequency spectrum shown, and then we can zoom in and see how this looks for the unit frequency. And we can see that it is levels 9 and 8 that are deviates, have a much larger value for this frequency, and we can plot the unit frequency as a function of crack size, and we see the same thing. But the difference is not clear on before you reach these latter stages of the crack propagation, which indicates that our analysis based on principal component analysis has some promising properties. So I thank you for your attention, and goodbye.